So for the participation asistencia, I put the points in the remarks. Yeah. Yeah. So it's out of 5. And if you have participated in the chat, you know, above average participation, you get 4. If you have the camera on, you get 1 extra point, you get 5. If you do the timestamps, you get 1 more point. So I can give you 6 out of 5 if you do all of those things. Okay. So that's how it goes. But everyone's gonna have one chance to do the timestamps. I want to reward you because you have to be extra attentive to everything. Um, okay, just yeah, put it in the chat. Any gaps, questions, comments. So you should be able to see the clave for the test from last week. You should be able to see your participation score from the last 2 weeks. And remember, it just has to be the best 5. Okay, so some people get a good start at the beginning, and then some people stay they come every week. Others come occasionally. There's some students that prefer me to speak in Spanish, but trust me, it's better in English with the translation. I wonder if I can turn on the transcript to Spanish here to translate. I don't know. I have to check that out. I will check that out in the break, unless somebody can tell me how to do that. I think I used to know. So if I ask for the transcript, okay, so if I say Spanish, is it going to translate? Let's see what happens. All right. Is there anything coming up when I talk? Okay. Oh no. It looks weird. How's the translator doing? I don't think it's good. No. It has to be in English. So I'm going to put it in English. How did I do that now? Transcription, show tran. Okay, you have turned on live transcription. I'm going to put it to English. At least that helps. I got to change the language. Transcript. But I have to put the language. No, put this again. Caption language is English. Yeah, it's not translating. I got to turn on a translator. I'll try that during the break. Okay. All right. So there we go. Oh, we're covering some names though of people. All right. So let's see what you have questions about. Today's quiz or test is going to be like last week. You only have to answer one. There's 2 problems. They're very similar. Where I'm going to ask you to calculate the 5 features and compare 2 groups. Okay, so if you don't know how to do that, you got to ask me now so we can go over it. But there are several examples where I did that in the videos and in some of the exercises, the homeworks and things.
Professor, can we go over it so we can refresh the 5?
Okay, tell me which one you want me to do. Just find the one you want me to do so I don't pick it. You guys can.
I think it's the one in page 17, I believe.
Okay, and then oh, the calculator. I put a video with the calculator because I understand, yes, um, in the lecture, the conference of the class, maybe I was looking at it, maybe I didn't have the calculator there. Usually I teach it here. I go through it here, so we can do that together. And then also I put a video from YouTube that's very good to explain how to calculate the basic statistics. Um, and okay, so give me a second. I'm going to set up my iPad. Okay, so I'm just seeing some comments. Dorimar, did I answer your question?
Yeah, I'll send you a follow-up email. I do have a question though.
Okay,
But
sure.
yeah.
Great. So Marilis, the clave for exam one should just be, you should be able to open that first test and you should be able to see your response and the clave should appear. If it doesn't, let me know and I'll look at it during the break. Yeah, this is a lot of work. There's a lot of questions here, but somewhat repetitive. And usually I leave 2 weeks for it, but I'm gonna cram it in to this week because um yeah, because it's just like that, and then you can catch up this weekend, and then next week is going to be normal distribution, and that should go quickly. And module 5 goes very fast. It's only about 10 pages, so you're going to catch up. It's very uneven. I don't know. There's no way I have been able to spread out the course because originally this course started with 15 weeks and they moved it to 12. So we're just going to suffer a bit at the beginning. The waiting room. Is the person still in the waiting room? I don't have any notifications. What happened to my translator? Yeah, I think I gotta turn this off. It turned back to Spanish somehow. That's not good. Oh, probably because I spoke Spanish or somebody spoke Spanish. It's sensitive. Maybe I'm gonna turn this thing off altogether and just rely on the review. Yeah. Okay, you don't see the clave. Okay, we'll look at that in the break. It's not so important as getting through this. Okay, let me get the problem. Okay, I'm gonna go in order. I mean, order of the notes pages. So let's see here. Oh, wait, so this, I make a video explaining, uh-oh, I turned on the transcript again somehow. Oh my goodness, so sensitive. What happened? I'm gonna have to leave it. And everybody, do you guys want me to review these calculations here? Comments? Javier doesn't want it. Does anybody want me to review the calculation? No? You just want to see the answers. Okay, just quickly. I think this is the best one here. This video was, I think this is the most important video. So I solve it all here. I solve it in the videos. if I have this data here, these are dollars. And the point is, with one data set, using the calculator, you can see both. I want to calculate the mean and standard deviation. So the steps are that we need to put the calculator into, first we have to put the calculator into data mode or stat mode, and that is accomplished by hitting second, you see that, the blue, and data, and then it activates a spreadsheet on the calculator. Now there's something in there already, and if I use the arrows I can go down through the spreadsheet, you see? Oh, there's two variables, there's X and Y, so this is actually ready for module 5, where we actually analyze relationships between two variables, but I just want to analyze one variable right now. So we can actually in the formatting, second format, setting up the calculator first is important. First of all, if you hit second format, I did second format, you see it says DEC and 9. The DEC stands for decimals. You want to see all the decimals, okay? So you need to change whatever number was there. It should have, it's probably 2. You probably have 2 as a default, so you want to change that to 9. To change it to 9, you just press 9, enter, and scroll down. So that is going to be 9. So that's going to show all the decimals that it can, 9 decimals. You're going to need that because we're going to work with probabilities or percentages, and we want to see at least 4 decimals most of the time. Okay, so you need more. I just put 9 because that's my habit in finance, because all those decimal places matter. Banks keep all those decimal places, so we should keep all those decimal places. Okay, so questions about changing the decimals. Next on the list, if I press arrow down, this is something about degrees and radians to do trigonometry. I don't want that. This is a dating system, which is useful for the accounting and amortization keys that we don't need that. US, I think this is US dollars is the base. There must be some conversions. I don't ever use that, but you probably can. And you want to make sure this one is AOS. Okay, so from the top, so 1, 2, 3, after the third arrow down or the fourth screen, it should say AOS. If it doesn't say AOS, it says CHN, which stands for chain, CHN. To change it, I think it's second set. So you would have this, CHN. You want to change it to AOS with second set. Chain means that it's going to calculate in the order you press the keys. But we understand that there is an order of operations in mathematics, and you want the calculator to use PEMDAS or BEMDAS, which is parenthesis, exponents, multiply, divide, add, and subtract. We want to use PEMDAS or BEMDAS. So we put it in second set AOS. And let's see, I think that's it. Okay, so you want decimals 9. Don't worry about this, don't worry about this, and don't worry about that. But change this one to AOS. Any questions? Got it? All right, and so now you're ready to go back to the worksheet in statistics. So there's several worksheets on this phone. On this app or this calculator. I'm using the professional version, but it looks similar, same as the physical calculator. There are a few different features, but we're not going to use those, so there's no difference. So I'm going to go second data. There's data there. In the worksheet, it's full or it's filled. So I need to erase what's there. In this data sheet and in the other ones, we want to clear it. There's several ways to clear on this calculator, but to clear spaces or memory spaces like this statistical data sheet, you have to clear all the worksheet. So to do that, you hit second and clear work. It will only clear if you're inside it. You can't clear the data unless you open the sheet. So now it's clear. So now let's start. Okay, if anybody has any questions, I can repeat. I can show weighted mean as well, Javier. Get me a problem so I can tell me which problem later after I do this one. Okay, so let's do enter the data. So we begin with 2, 2, enter, and then go down the sheet. And it's asking me for the second variable. We can actually set up the calculator to be one variable at a time, or we can just continue and just ignore y, just scroll through it. I can do both. Let's continue like this. We're just going to leave y like with the default of 1. Scroll down again. The next value is 8. And we're going to leave that, scroll past that second variable. The third one is 10. Enter, down. Scroll past it. The next one is 16. Enter, down. And we're not going to put y, so we scroll past it. And finally, 5, enter, down. All right, let's see you guys catch up.
I'm sorry.
I'll start
I'm
over.
lost.
It's okay. Where are you? At the beginning?
I hit second data and I'm on an X.
0, 1.
Yes.
And then
X
is there nothing there, or 0 there, or what number is there on the side?
0. I have
Okay.
0.
Okay, so just did you hit second clear work in case to wipe out the memory?
Yes.
Okay, now we're going to start from the top. 2,
Second data. Then I have X, exacto. 2.
enter,
Okay.
and scroll down.
To scroll down, do
With
you
the
mean
arrow down, flecha,
the
flecha down.
arrow down?
Mhm.
Okay.
Okay. And then we're not going to use the second variable y. We're going to scroll past. But now we're
Okay.
ready for the second one. Ready? 8, enter, scroll down with the arrow flecha down.
Mm-hmm.
Skip y, scroll down, and then 10, enter. So really it's down, down. It was 2 times.
Exactly.
Then 4 is 16, enter, down, down. And 5, enter, down, down. And it shows 6, but we just scroll back through it and it goes back to 1. So there's the data. Make sure you have the numbers correct. Verify.
We scroll back.
Just don't put anything, just continue down and it will pass. If you don't enter something, it knows you're finished. So we finished and now we're at the top. Keep going. So it just goes down and then back to the top. So let me know when you're ready.
I'm ready. Come on.
Okay. And now we're going to get the statistics out. So second, stat. You see stat? Lado of data, the side of data. And it says lin. Lin stands for linear. The calculator can compute linear relationship statistics. That's what lin stands for. And we're going to do that later in module 5. But for now, we're going to scroll through the results. Okay, so this has the statistics results. If I use the arrow flecha down, it's 5 is the n. Remember, n is the sample size. X bar, what is that? What is X bar?
Mean.
The mean. Ah, you said the mean. I thought you said something else. Sample mean, right? The sample mean. Be careful. Just to be clear, it's the sample mean, which estimates the population mean with the symbol, the Greek letter m or mu. All right, we're going to scroll down again, and we have this. What is this one?
Standard deviation.
Of the sample. So this is a sample. We have to be clear. Remember, from beginning to the end of the course, we have to be clear. What is a sample? What is a population? This was just a sample of students' money in their pocket that they're going to spend in a cafeteria at school. That was the story for this data set. Okay, that's the sample mean. What is this then? Sorry, this is a sample standard deviation, but what is this? So let's repeat. We have the results. N is the sample size, 5. X bar is the sample mean. SX is the sample standard deviation. And then there's this one. What is this? Dorimar is right. Not the variance, Gerardo, but I'm going to clear this up now. This is the population standard deviation. I have a page where I explain that if we believe our data is census data, it's the only data that there is, it's not a sample, but it is the population, then the standard deviation is calculated differently than if it was a sample. When it's a sample, we divide by n minus 1. The deviations from the mean squared are divided by 1 less than 5. In other words, this one is the average dividing by 4. If you divide by 4 instead of divide by 5, you get a bigger number. So this one is the average of the deviation, squared deviations from the mean divided by 5, so it's smaller. This is the one we use, the sample standard deviation, because we have a sample. But the calculator doesn't know. It doesn't ask us. It doesn't say, oh, do you have a population or do you have a sample? Instead, it just gives you both calculations and you pick the right one. This is critical to understand. You don't take data and put it in a black box like a calculator or put it in a computer. However powerful your computer is, you have to pick which statistics to use, unless you're using AI. It will know most of the time. I mean, for basic stuff, it knows what to do. But in general, you need to be the decision maker. A calculator that just, or Excel that just makes calculations, or software of statistics that just gives you a bunch of results, you have to know which ones are useful, okay? So it's a sample, you use that one, not this one. If I continue scrolling, first, did you guys follow? Any question? So this is if it was a census or a population data set. I think 99.9% of the time in my class, I'm going to do this. Sometimes, maybe in some of the exercises, you might see that we're working with a census. Similar with Excel. If you're going to use Excel to make calculations, there's both of these calculations. So you need to know the origin of your data, if it's a sample or a population, to know which one to pick or ask for. All right, so then now it tells me the Y results, but we didn't enter data into Y, so there's nothing here. So it has results for Y, the sample mean of Y, the standard deviation of the sample. And if it's a population, it gives you the population. It's 0, right? Why is it 0? Does anybody know? Why are these 0? Why is this mean 1? So let's go through the data again. Let's look at the data again. Okay, the data was 2 and y was always 1 all the way through. Look, y was 1, y was 1, y was 1. It means that if they're all 1, what is the average? If they're all 1, what is the expected value? If I want to make an estimate of 1, 1, 1, 1, and 1, I expect 1. Okay, so that's the sample mean. And what is the variation? Is there any variation? If the values are 1, 1, 1, 1, 1, no. So there's 0 variation. That's what that means. So there's no difference. Okay, so that shows there's no difference. That's what the standard deviation is telling you. There's no variation at all. Okay, and then these results we're going to learn about in Module 5. These are the results of the linear relationship. These are, if you remember, a line, and I give some review of making lines and equations of lines that you learned in high school, because we're going to use it now for these exercises. This is the y-intercept, this is the slope, and there's no result because there is no relationship. Okay, so don't use any of that. So what if I wanted to get rid of y? I think I can do it in stat here. Wait. Okay. Let's see if I can, yeah, I can change the mode. So let's go through this if you guys watch. I'm just like, it's like changing the format. All right, so I'm just going to scroll through. So the options are linear, logarithmic, exponential, power, and one variable. Which one of those you think I should try? Which one? So if I put one variable, Dodimar suggests what's going to happen is it should just ask me for x. Okay, it should ask me just for x. So if I start entering data, oh no, it didn't work. Or it just gives me the results of x. I guess that's what's going to happen. So if I go through my results, it just gives me the x results. Yeah. And then it goes into, it gives me some other values. This is, what is this? This is the sum. Remember this symbol? If you watch all the videos, I'm assuming you watched most of them, okay? I talk about the summation symbol. This adds up all the values. This one squares, so it gives you a squared sum. And that's it. So it just talks about x. It doesn't talk about y. But I'm going to turn that back to linear because I know that I just have to ignore the y results when I use one variable. All right. So that's it. That's the mean and standard deviation. I showed you about format to make sure the format has 9 decimals and that you wanted to have order of operations AOS as the default. I showed you about stat mode and the data entry mode and clearing the worksheet. So I cleared it again and it's gone. I have to re-enter. Don't clear unless you have to because it's nice to have your data stored. All right. Okay, so any questions? Do you want me to repeat? Are we good? I'm going to do the weighted mean now. So Javier, did you find me an example? I think the next page or something. Oh, towards the end. You guys can tell me to repeat if you need it. So if I continue through the notes, there is a weighted mean example over here. there, right? So there's a several examples. So you maybe you didn't make it this far. It's going to be okay. You have time this weekend to finish with this material, page 23. Right. So those are weighted mean. So let's do this one. You can do the weighted mean on the calculator, but not the weighted standard deviation. Okay. So I explained in the video the difference between a weighted mean and a mean. Can somebody tell me what is the difference? Or you guys all tell me what is the difference between a weighted mean and a mean? Look, it turned back to Spanish again. See, people tell me how smart AI is, and I'm still struggling to believe it. It's not really AI. But it's a start. So my question was, what's the difference between the mean and the weighted mean? You guys should all be able to tell me something about it. Even if you don't know, you can tell me you don't know. Yeah, it's hard to do in this mode. That's my problem. Okay, I'm gonna have to speak 100% English or this thing is gonna turn on. I'm gonna stop sharing for a second. It's terrible. Okay, should hide it now. Okay, back to thing. Okay, so what are you telling me? Okay, so there are 3 exercises that I introduce in the weighted mean documents or pages because the data can appear different ways, but it's the same idea. Unless every piece of information, every data point has equal value or weight of information, you will have to calculate a weighted mean. So here, the most likely observation are 8 and 16. Okay? Their chance is 30% of appearing, and the chance of 16 is also 8 and 16 have a 30% chance of appearing. The other ones have a less chance of appearing. In the data that we just analyzed, we took every data point equally significant or equally important. We didn't, in other words, what we did, we had a weight, but the weight was the same throughout. So there, you could imagine a PI here, but there's 5 values, so each one was 20%. Do you understand? And the weights have to total to 1. So 5 observations, 1/5 weight each, or 0.2. I don't have to put it though, because that's what we do when we divide. We add them all together and then we divide by the 5 after, okay? So that is how the regular mean is a special case of the weighted mean. The regular mean is a special case of the weighted mean. The weighted mean is more general. Unfortunately, in statistics, we use the same symbol, whether it's weighted or regular. Sometimes they put a W on it or something, but it looks weird. So you just have to know if you get 2 columns of data, then you know. If the probability of each observation varies. So the regular mean is a special case of the weighted mean. So back here, what I'm going to do is, okay, wait, let me ask you, what do you think you do? What do you think? Any instincts? Because, you know, at some point we've all had to deal with numbers, analyzing numbers, and we have some sort of intuition of looking at numbers. Humans had to work with numbers in transactions and trade. So we have instincts about numbers. So what do you guys think? With your calculator, what can you do? Do you see two columns? Maybe you see an X and a Y? I don't know, maybe. Enter X and Y. Enter X and Y. So what's the formula here? X bar is equal to the sum of xi, pi. So we have to multiply these like this, and then sum. We can do all of that in the calculator, and I'm going to show you how. So enter this one as X and this one as Y. So let's do that. Are you with me? Who's with me? You don't have to multiply. You can multiply manual, but I'm teaching you how to do it on the calculator. You asked me, right, Javier? So this is how you would do it. So enter 2. And first of all, clear your memory, which I already did, but you should clear. So 2, enter, scroll down, and now put Y as 0.2. 0.2, enter, down. Second one, 8, enter, down, and 0.3 for Y, enter, down. Now put the third one, the third pair. 10, enter, down, and 0.1, enter, down. And the next pair, 16, enter, down, and 0.3, enter, down. And I can repeat, so don't worry if, I think I did too many now. What happened? Am I on 5? Okay, let's see, repeat. So it was 2.2, 8.3, 10.1, 16.1. Okay, and the last pair is 5, enter, down, and 0.1, enter, down. And I've entered all my pairs with weights and score, right? I call it score is the value and weight is the probability or proportion or percentage. And drum roll, please. Use the flecha going up. Second stat, use the flecha going up, and that is your answer. This is the product, the sum of the products of the two columns. And you can verify either using Excel or doing step by step, but that's how it works. So, should I repeat? That's right, Kimberly, 9.1. Is there something blocked? Can you not see the screen totally? Let me see. Yeah, you should see the screen. Anybody want to see that again? Otra vez? Oh, I can't speak Spanish. Oh, I turned off the transcript, so we don't have that problem right now. Okay, let's do it again. I'm going to clear my work. I'm going to go back, second data, clear my work, and entering in pairs X, and this is going to be Y. 2, enter, down, 0.2, enter, down. Second pair. Eight, enter down. 0.3, enter down. The third pair. 10, enter down. 0.1, enter down. Fourth pair. 16, enter down. 0.3, enter down. 5, enter down. 0.1, enter down. Got it? Now, second stat, and use the flecha going up. And that's the answer. Yeah. Once you have that, to finish the calculation, you use that sample mean and do columns like you would the deviation from the mean. So what I'm showing you right now, these are really important videos, okay? It's very important. This is like this, if anything is more foundational than this, I don't know what it is for what you're going to do in the class, but this is it. You're getting a measure of expectation or expected value as the sample mean, and you're getting the standard deviation, which is also a sort of a mean, but it's the mean of the deviations, the average of the squared deviations. So statistics is about means and relative measures. This is a relative measure. I'm putting everything in relation to the expected value. And that's what statistics mostly are. Okay, so I made the calculation of mean and standard deviation. Well, not here. You would have to finish this manually unless somebody figures it out how to do it on the calculator. But I've never, well, I know a way to do it on the calculator, but that means I have to teach you a different formula, and I don't want to add more formulas. That's why I hesitate. But if you have to get the sample standard deviation for, or if you have to get the, deviation, standard deviation for this data, the weighted standard deviation, then you got to go step by step with the table. So what I want to say, going back to the original data set, this page is very important, as I've already stressed. What I do with the mean and the standard deviation, if I ask you to, so let me go back a minute or a second. The standard deviation, if I ask you for it, you don't have to do all the steps, right? This is just to explain to you where this formula comes from. In contrast to this one, which is the population standard deviation, where I divide by treating the sample size as the whole population and treating the mean as the population mean. So this is the formula if it's the population data. This is the formula if it's the sample. And as I explained, you're dividing by a bigger number here because this one is treated as the sample minus 1, but this one is, and this is the population size, the same number, and treated like a population. So this one's going to be a little bit smaller. So how do we use the mean and standard deviation in reporting? I go through this explanation here and describe how the data are spread out. So with the mean and the standard deviation, you can describe the distribution of the data, and that further tells the readers or your audience what to expect. So if you haven't, make sure you watch this video and I explain it all. You do this, you make these calculations. Now, this is the important part for the test today. Oh, well, everything I've said so far is important, but I want to stress that you calculate the mean and standard deviation, assuming the data are symmetric. Okay, that's used when the data are symmetric. So for the 5 features, the first step is to determine the shape of the data's distribution. We have very few observations here. So we're really essentially assuming that they are evenly spread out, which symmetry implies that there's some regular appearance of values in the middle, and then there's a few that are lower and a few, just as many that are higher. So in this case, it's 8 was the mean. So that was the center, and then below it is 5, but then above it is 10. So they're not exactly equally spaced, but there's so few data, we can just assume. Okay, we're going to say it's equal enough space. And then further away from 8 is 2 on the low side, but then above it is 16. So it's not perfectly even with 8 in the middle, but we're going to assume that it's symmetric, and if I had more data, it would continue to show that pattern, that the data appears equally around the average, the sample mean. If the data are not symmetric, or you assume that they are not symmetric, what do you do? What do you calculate? So the 5 features are shape, 2 is center, and 3 is spread. So I've covered all of those for symmetric distribution. And then the 4th feature is gaps and outliers. And the 5th is peaks. With the 5 features, you can summarize small or large data sets so that people can visualize the data and make conclusions based on the question posed with the data. So you're given data, you're given a question about the data, and this will help you answer that question if you, in a systematic way, describe the data, summarize the data. If the shape is symmetric, this is how you get the center and spread. So let me take this to another page so I can just continue this. Are you guys with me? For me, I'm making sense, but it needs to be for your sake that I'm making sense. So are you following? Oh, gee, that didn't work. Sometimes my copying doesn't work. Try that again. I think there's a new version of this. Oh, no, that doesn't work. I can just write it faster. Okay, so for symmetric, if the shape is symmetric, you proceed with the center, you calculate X bar. And this is if it's a sample, right? Trust me, it's going to be a sample unless, I spell it out clearly that it's not a sample, that it's the population, and then you would use mu as your symbol. This says otherwise. For the spread, you calculate S, which is the sample standard deviation. And what about the gaps and outliers? How do you do gaps and outliers for symmetric data? And so this is under symmetric. Do you guys Did you guys get there? Did you get that far? So you're going to use a stem and leaf plot to see all the data. I have to write a little more clearly, I know. So using a stem and leaf plot. Identify any gaps, okay? Or list any gaps. And for outliers, how do we check? Again, did you see that? Did you get that far? No? So what you have to do for outliers is okay, so outliers will exist if there's data outside 3 standard deviations from the mean. So you have to take your mean and you have to add and subtract 3 standard deviations and then go back and check, is there any data there? If there's data there, then you say there are outliers and you can list them. That's how you do this for symmetric data. How many people saw that or got that far? So that is how you deal with symmetric data. So I did it here. I checked. This is how you check within 2 standard deviations. So here's the mean, here's a standard deviation, and you do plus or minus, you go both ways, above and below the average, checking the data. And this gives me this interval. And then you go back to the data and you make sure that all of the data is inside that interval. There are no numbers lower than 2. So on the low end, the data fits. On the high end, there's no data bigger than 18. So 100% of the data is already within 2 standard deviations. So there are no outliers. Okay, it's not that spread out. Not too spread out. So this comment here is just saying the same thing. There's only outliers if there's data outside 3 standard deviations. This is an example. There are no outliers. Okay. If you guys are good with that for symmetric, let's go to asymmetric or non-symmetric data, otherwise known as skewed data. Oh wait, I have to do number 5. Peaks. For peaks, you have to list the modal class of all the peaks. All right, what all the peaks? Well, this can be symmetric if the data looks like that's symmetric. But also, that's symmetric too. So you would have to talk about this peak and you have to talk about that peak. The modal class is the one where the peak happens. So this is bimodal. and you have to mention both, positions of the peak. Or peaks. Okay. All right, let's go to skewed. So, whoops. What if the data are skewed? I'm going to use black or blue or something. All right, 2. Not 2. 1. Shape. For skewed data, what is the center? What is the spread? And how do I identify gaps and outliers? Oh, this is like a review. Okay, Modoni Mars got it there. So I'm just going to copy. Its median is the center. The spread will be using the 5-number summary. I'll leave some room, which includes the minimum, Q1, Q2, Q3, and max. If you guys didn't get this far, you have to hope that the distributions I give you are all symmetric. But otherwise, let me know, and maybe we have time to review that too. Okay, so minimum, max, the highest value and the lowest value, that's easy. This one is just the second quarter, or 2 quarters is 50. In other words, this is the median as well. And this is the median. Well, these are also medians. This one is the median of the first half of the data, and this is the median of the second half of the data, divided by eliminating the median. And then, or you can also mention the range here, which is the maximum value minus the minimum value gives the range. That's another thing that people report as a spread. For gaps and outliers, again, do the same thing as you do here. Oops. I don't know what that is. It's like a capture. No, that's not what I want to do. Do the same thing here. So for gaps, using a stem and leaf plot list classes where you see gaps in the data. And outliers are found so they exist outside the regular spread of the data as defined by the IQR, the interquartile range. The interquartile range is the range of the middle 50% of the data, which is Q3 minus Q1. So this is like the 75th percentile minus the 25th percentile, which leaves you 50% in the middle. So this gives you an idea of what's happening at the center of the data. And it gives you the regular pattern of the data and how spread out the data is, how much variation there is. Kimberly, what are you referring to if you make an incorrect calculation? Just, I mean, if you make an incorrect calculation, how can you check it? Well, this is a moment I can tell you. When I studied statistics, I figured out 2 or 3 ways of doing problems so I could always check myself on a test because obviously you don't have the answer key, so you need to know how to check your work. So always have 2 ways to confirm or 1 or 2 ways. So I don't know. How can you detect if you're making a mistake? Think about it. There's basically, you have to practice enough problems and make mistakes enough to find where you're making mistakes. At this point, at this moment, that's what you got to figure out. You got to catch yourself, bad habits and things. For instance, the median divides the data into the first half and the second half. Or the upper data or the lower data. It divides it in half. Which half does the median go in? The first half or the second half? Trick question. No, the median goes nowhere. It divides the data. It doesn't end up in the halves, okay? The median splits the data and it's not in either, okay? So that's very important. Students miss that a lot. So things like that, I know what you guys are going to miss because I've done this for so long. You're going to have to know and catch yourself by practicing at this point. Okay, I'm almost done and then we're going to take a break. So outliers exist outside the outside of what? 1.5 times the interquartile range. Okay, so what we're going to do is find the middle half of the data by making this calculation. And that gives us the spread of the regular portion of the data. And then what we're going to do is check on either side of the first quarter and the third quarter. So the data are laid out like this. We split the data in half, and the first half has a median and the second half has a median. And between those two is 50% of the data. Then we take that spread and we extend it going this way and we extend it going that way. And if there's still data beyond that spread, like I gave it, I was very generous and said, okay, I don't want the data to be too far away or it's going to be too spread out. And what is too far is defined by the variable itself, the nature of the variable itself. So I'm going to use the nature of the 50% of the data in the middle and then extend 1.5 times IQR that way and 1.5 times IQR that way. And if there's still data, that means there's outliers. Okay, that's how it's done. Okay, so that's the outline. Oh, and let me do the last one and peaks. The peaks are the same. This is going to be the same logic. Okay, so nothing much to say there. Questions? So that's the outline of what you guys got to do. One added thing, I'm going to give you 2 data sets that you have to compare. To compare those 2 data sets, create a back-to-back stem and leaf plot. And then make these calculations so you can stare at the data back to back. Um, the outliers are beyond. So outliers, hold on, let me see because hold on a second. Yeah, so the terminology about the whiskers is the lines extending from the box to the minimum and maximum values within like doing this. So whiskers will go out to this end. So this is like the whisker and it'll go out to that end. Anything beyond that will be called outliers and they will be drawn separately like this, you know. Like that. So box plots are the graph that presents the 5-number summary. And I have many examples of that. The whiskers are extended beyond using this calculation. To the last, it goes up to the last value in this range. Right. And outliers are beyond the whiskers. So, um, so if there's no data, so if the whisker, if there's data outside, it will go this far. But if, so let's say there's no whiskers on this side here. I mean, there's no outliers on this side. The whisker will just go as high as the data, and then it will stop. Anyway, let's see. Okay. So like the whiskers stop with the highest value if there's no outliers, or the lowest value if there are no outliers. If there's outliers, it goes all the way to the end, and then you show the extreme values. Okay, so let's take 5 minutes, a little break, and let's see if there's any other questions, or we'll just do some exercise. I got to show you, I'm going to talk about the back-to-back stem and leaf plot, right? And that is with this data here. I show it in the videos, I believe. Sorry. Two sets of data. Yeah, it's this one with these two guys. So let's take a 5-minute break, and when we come back, we're going to make the back-to-back stem and leaf plot of Ruth and Maris, unless you guys have another question. I'm going to look also if there's anything outstanding people ask me. Eileen, did I explain the interquartile range at all for you? Do you have still questions about the interquartile range?
I'm more clear now.
Okay, good. It's good to see in the context of the whole thing, I guess, in the summary. I'll go back. I mean, it's not the neatest, but you guys can screenshot this if you want. You guys can use your notes, for the quiz, but for the quiz or the test today, you're going to write it on paper and you're going to upload it, I think is the best. Okay, or I will ask you to do that. You have to upload it. Have to upload it. So get ready for that. Okay. Okay, let's take that break. Let's get back at 10:25. Closer to 10:30. Okay, see you in a bit. I'm gonna stop or pause the video. Okay. As far as I don't know why the quiz doesn't show the results, I have to figure that out. I have another way to put in the right answer. I'm going to try that for now, but I'll do it after while you guys are doing the quiz or the test. I'll try and fix that. Okay. Let's do the back-to-back stem and leaf plot for Maris, or should we go to the serial? Let's see if we have that in the serial too, right? Let me share. Okay, you got to remind me where the serial is. You told me number 2 problem practice. In the first practice or the second practice? I think it's the first practice, right?
Mm,
No, second practice. Uh-oh, something didn't show. Where's my serial?
Hmm.
Is it here? It's supposed to
No,
be.
I thought it was the first one.
There it is. I don't know what that was. Oh, that was the clave I opened. No, I don't know. Something's messed up. Let me do this one more time. So this is the first one.
Yeah, there
And
it
the
is. It's number 2.
clave of the first one. Is this the wrong clave or is it here? No, it's the wrong clave. So you don't have a clave for this?
I think
Or did I mix
it's
them up?
there.
Oh, it's here. Okay. So here's the back-to-back stem plot. Let me make it bigger. So you should have tried to do this on your own first. It's question number 2. Of the second one? The first one. It was the first one. I feel like I'm doing the cups game. Okay. So the second question of the second practice assignment, you want to compare 2 groups of data. A couple of things to begin. First, I multiply all the values by 10 to make the stem and leaf plot. It's just easier to divide up and I don't have to work with the decimals. So that's what these numbers are. Then I put them each in order. So these are put in order. These are put in order. And I decide that there's enough data, 12 in this first group and 11 in the second group, that there's enough data to see some change, but it's not a lot of data. So I'm going to go by 2. I'm going to go by 5. Sorry, I'm going to go by 5. So each class here has 5 observations. This first class, how would you define this first class? What is the range of values for this first class here? This includes 0.5 to 0.9. Very good, Natcha. 0.5 to 0.9. The 0.5 and the 0.9 has to have 0 to start because that is common. And then only that's common stem here, 0. That's the first digit. And then the leaf goes here. That's the hoja, the leaf. All right, so that's why 8 goes here and 0.6 goes here. The next one is going to be 10 to 14 because that includes 5 values, 10, 11, 12, 13, 14. So this is the stem is the first digit 1 and the second digit is 3, so 13, and then 1 and 2, 12. That's how it works. There's no data here, but we still have to impose a ruler, the same ruler to both, and then we sort the data around and we see the differences, and that's what you're going to comment on. You're going to make the 5 feature calculations and comment on the differences. We begin with the shape. Okay, first of all, does everybody know how to draw this? I don't know if that was sufficient, my explanation. Anybody want more clarification on how to draw this? Because you're going to have to draw this. Okay. So what do we see? Number 1, shape. Oh, Javier, you want me to draw it? You want me to show you to draw it? Well, I'll do that after because we don't have much time. And that's pretty basic. So let's say I gave you this drawing. You smooth out the data. When you smooth out the data, what you're saying is that I believe if I had more data, the shape would be like this. Now, some people might think, but there's 2 peaks here. And that's okay. If you want to do that, I don't know, that's up to you, but you have to have a justification that you believe this gap here, or not gap, but this will fill out. When I draw it like this, I believe that more data, this will all fill out. That's what the smoothing does. So over here, my decision is I don't see this as many peaks. I see it as 1 peak because most of the data is here. And otherwise, if I had more data, I believe the shape would be like that. All right. So what do we say group one? What shape is group one? Symmetric or skewed?
Skewed.
It looks pretty skewed, right? Most of the data is on one side and a few observations are on only one side. So it's not balanced. So it's skewed. And is this right skewed or left skewed?
Left.
Let's see, put it in the chat. What do you think, guys? Someone said left, someone said right. Okay, so many said right, some said left. Okay. You have to look at this number line here and you imagine turning it horizontal. Now, when you imagine putting it horizontal, what side is the tail? What side is the skew on, left or right? So you have to imagine if I take sorry, let me see if I can, if this is worth it. This is all explained in the videos, but I guess I have to do it. No, I'm not going to be able to do it here. I have to do it on the iPad. It's right skewed, Gerardo. It's right skewed, Ernick. Okay, because the large numbers are on the right side of a number line. To put the values on this, all the numbers go from small to big out to the left, and the numbers this way go small to big out to the right. That's how you see I have, this is 32 and then 33. This is 25 and then 28. So the number line is like reverse. So you have to realize if I turn that horizontal like a ruler, that's going to be on the right. Here it's easier because you can read that's on the right. So anyway, this is going to be right skewed on group one, and group two, do you think it's skewed or symmetric? Okay, so we're gonna stick our neck out and say it's symmetric. There's a pattern of accumulation here, but we have some values high, some values low. If in doubt, what should you do? If in doubt between skew and symmetric, what could you do to resolve it? What is one thing you could do? Anybody know? Very good, Marilise. You calculate the mean and median, and you see if they're basically the same, or at least in the same class. If the mean and median are in the same class, then you can say it's symmetric. You can, you can if it's close or borderline, you can say approximately symmetric or something like that. I'm putting it in the chat. Okay. All right, so now we have to go through and calculate the statistics for all of this and then make a statement about what we think. So here, the shape, the center, the spread, the gaps and outliers, and the peaks. And that should be in the clave of number 2. Oh, I don't know. This looks confused. This is like something else. Oh, it's on the same page. That's right. It's down here. Okay. Very good. No, it's not down here. Where's the clave for this? Do you have it or do I have to make it?
It's somewhere. It's there, but
It's lost. It's here.
it's yeah.
This is it here. Number,
No.
no. I know
There's
it's
one
here.
that's
Here.
that's that
Okay.
one.
It's in,
There.
okay. So, oh, you guys have to tell me when I screw up. Sorry. So it is one. It's in number one and it's in the solutions one. Okay. So here it is. So here are all the calculations and then the conclusions. I make all the calculations here.
I had a question about the peaks though.
Uh-huh.
It
For
just
which?
didn't make sense
For
for
a group,
group two.
for group two?
Yeah.
Group two is one peak. All right, so then let's talk
Or
about the
sorry, group
results.
one.
Let's talk about
Sorry.
the results. The results, notice, even though the drawing was multiplied by 10, for the drawing, I multiplied each value by 10. My results refer to the original data. Okay, that's very important. So these numbers have the decimals. So you have to remember that. Whatever you calculate, put it back into the original data by dividing by 10. And then the peaks. So one major peak with center. Yeah. So basically, this is always uncomfortable, right? Because there's a few data. It's very uncomfortable. That's the idea of asymmetric data. It's not reliable, right? Symmetric data is reliable, and you know where things are gonna land, and you can make bets or you know, this is your expected value. It's not so clear here. So that's what I'm stressing. There's a peak kind of here between here and here, and that's all I express, I think. So what did I write? Let me erase that. So I wrote from 2 to 2.4 with the center. Okay, there's one major peak, and I just remember I said get the mode of the peak. That's all you have to present. So the modal class of the peak, if I think this is a peak and I drew it like this, I believe that this will fill in. It's not two. If you put two peaks, that's okay. I don't mind. As long as it's, you know, I can't prove any different. I don't have more data to prove it. But if I draw it like this, I think that this will be the middle, the modal class of this big peak here. Not big, it's flat. It's not really peaky. But this is the center. It's not the modal class, it's the center class actually. But I imagine that there's going to be more data, and that will be that's my center of the mound of data. That's what I present. If you want to do it different and you want to say that there's two peaks, then you would present, you know, these two and say that's kind of like the center, but you don't have enough data to say. Is that a good answer for you, or should I say more? It's very clear here. That's the nature of symmetric data. It's very clear. Skewed data is very uncomfortable. So I'm very lenient with grading in that case.
So I guess if I were to answer that it was from 1 to 3.3, is that the wrong answer?
No, I would accept that. It's not a peak, you know. It's an accumulation of data. If you said the data is flat and there's no real peak, but the data occurs in here, that also is an answer. What did I write here? One major peak. So we believe that more data will so if I say that, I have to stress that I believe there's going to, if with more data, that would be like the center of the data, where that's where the median would fall, sort of thing, because it's skewed. But otherwise, if you just said it's very flat and there is no peak, that would be correct. Or if you said what you just told me, that's saying the same thing. There's no real peak. That's fine. It's again, just say something to the effect that it's not clear, but something like that. It's not so clear, but I find most of the data in this in these classes. So I agree, it's not clear.
Professor, is that the reason why for group two you say it can be both like symmetric and you give the option of saying it's skewed at the bottom of the
Exactly,
solution?
because there's not a lot of data and yeah. And I gave option 2 because people really saw left skew. And you know, if you're writing on paper, I recommend you use a graph paper or a ruler to help you because that can really mess you up. You're going to think it's skewed, you know, if you don't have it so neat as I do, this is going to look maybe a little further and you're going to think it's skewed. And I don't want to penalize people. It's not great. There's not a lot of data here. You know, 10 observation isn't a lot. Not to say clear patterns. So this is kind of like what data looks like in all honesty, unless you have big data nowadays, we have lots of data to work with. But this is what this is, you know, to get one data point costs a lot of money. You know, interviewing people or surveying or collecting here, like doing experiments and measuring, you know, it costs money. And so it's natural for there to be few data points and you have to have sort of a rule to deal with it and you have to be yet flexible. So you're sharing the information and the uncertainty or the ambiguity of the data. All right, so I was going to do the back to back or something. Okay, so you guys tell me which of any of the calculations you want me to talk about. So this is easy, right? The symmetric one now, you know how to do the mean, the range, the standard deviation. I told you how to identify outliers after 3 standard deviation. That's all clear. I mean, you just have to practice to get that right. On this side, it's just, I think, maybe just finding the outliers, right? And here I do the calculations. I mentioned the gap in the data. The gap is where there is no data. So let's go see from 4.5. So from 45 to 49, right? There's a big gap. You see, 45 to 49 is a big gap. This one could be mentioned too, but this is the big one. And then to make the calculation of the outlier, you see, you calculate. So just do the steps. Q3 minus Q1. Do you guys want me to do this 5-number summary at all, or I'm trying to manage the time here. I don't have too much time. Do you want me to just do this part together? I'm going to download this. No? I have to put this in a special place. Yes, Dorimar, you're gonna take a picture, make a PDF and upload it to Moodle. There'll be a box you can upload it in. Okay. Okay, I'm going to share on my iPad. Oh, I need to get that too. This one. Somebody asked for GDS 17. Do I need to do that one too, or? Mirangeli, you can use a tablet and an app and writing. That's fine. Just take a PDF or however you do it there and send it. That's fine. Yeah, as long as you're writing, not typing, not typing. I want you to use your own handwriting. Okay, I want everybody to do it in their own, with their own hand. Okay, you see. Okay, so this is what we're talking about. So back to the topic of the number line. So if I take this and I gotta flip it. Oh well. So I want to put it on its side, but then I want to flip it because that will look like left skewed, but that's not the way the number line goes. The number line goes the other way. So I need to flip this, and I'm going to do that with my drawing thing. Is going to help me. Things are changed a little bit here. Anyway, align. Can I do that? No, it won't let me. Okay, anyway, so I'll have to figure that out with this new update. But you should be able to flip that and you see that it goes right. Does everybody see that? If I, it should be on a, so for like a ruler. And so for the data here, the steps are to put the data in order, but you can do that with the decimals, or I times everything by 10. So that's the first step. You can also do this in Excel. You guys can use Excel. You can put things in order for you. You guys have some advantages because you can use whatever you like. Just means you have to learn all the tools. So you can sort these. But so I'm going to put this as 60, 25, 32, 33, 0, 8, 1, 3, 1, 6, or 16, 16, 12, 44, 28, 21, and then you put them in order. The smallest one is 0.8. Then we have 12 and 13 and 16 and 16, just to give an example. So then I put the data, so I have 12 observations, and I put in from the lowest to the highest, looking at both data sets at the same time. The first class is going to be between 0, 5, and 0, 9. And between 0, 5, and 0, 9, this is the stem, and this is the leaf. So all the values that share the same stem go here on this side, and this for the other group. The next class starts at 10 and goes to 14. All classes have an interval of 5. So that includes this one, all of these, well, these two anyway. So this is going to go in the first one. These are going to go in the second one. The next one is going to start, I hope you're watching, Javier, 15 to 19. Again, they all have to share the same stem. That's why I have to use 10 to 14 and 15 to 19. I can't go to 20 because 20 has a different stem. The next one will be 20 to 24. I can barely fit it in there. Questions, Javier? Do the best you can with graph paper. Keep everything in alignment. And notice as I put the numbers down, 12 goes first and then 13 on the left side. On the right side, it's like a regular number line from small to big, but you go backwards on the left side. Okay, so what else? All right, so I was going to do this, right? Okay, so the idea is I think it's best to show this. I mean, I can do the calculations here step by step, but I think this is best illustrated with the notes and the actual proper drawings I have. If I do it here, it's not going to look so neat. It's going to look messy. The best way to do this is to watch the videos or review what I did here, right? I'm going to grab the annotated notes. That's going to be the one with the best description of interquartile range. Is that okay, guys? I'm going to grab the annotated notes of the spending data. I think that's the best for the IQR. So probably you didn't get through all of this. Try and finish that up today. I'm giving you a very basic test on this, like a summary, the 5 features, very practical. And like I said, you only have to do one. If you don't like the one you're working on, you can go to the second one, but you can't go back. Remember that. You know what I'm going to have to do is okay, I'm doing this because I have everything laid out. So you're going to need a ruler to do it nice. There we go. See? Look at that. So let's talk about calculating the 5-number summary. And Maris has the funny data. So let's do it for Maris. So this is what I'm going to do. First, you put the data in order. That's done here. Then you find the middle. You could find the middle or the median by crossing out on both sides. This is a technique that for small data sets that you can use to find the median. So I could do that. So cross out one there, cross out one there, cross out one there, 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 there. Aha. There's no clear middle. So I have to average those two to get the median. Got it? The other way to do this is to do n plus 1 divided by 2. And there are 11 divided by 2 or 5.5. That will give you the middle observation. Again, because it's a fraction, it tells you that it's between 2. So 1, 2, 3, 4, 5. So it's 5.5. It's between those two. The best we can do is get an average. So we compute an average, and that gives us the median. So the median is 24.5. So now we have, for a 5-number summary, we have the median, we know the minimum value and the max. So we only have to find the median of the first half and the median of the second half. The median is not part of either the first or the second half. So it divides the data in two. Now the data is in half, I can see exactly my median. So this is Q1 and this is Q2 or Q3. This one is Q2. So I have my 5-number summary. Now I'm going to put the 5-number summary clearly down. That's here. Minimum, maximum, median, and the Q1 and Q3. See how fast I did that? Now we're going to make a nice number line evenly on the paper and mark them. Please watch, because either you saw this or you didn't. This is the best way to remember this, because otherwise you're just making calculations and you don't know what you're doing. This is the visualization. This distance is called the IQR, the interquartile range. This is how spread out the middle 50% are. So this shows the regularity of the distribution. I'm going to use that and impose that on both sides. Well, there's no outliers here, right? Because this is not more spread out than this. So I don't even have to test that side. I'm just going to test this side. How I'm going to test it is I'm going to take this distance and I'm going to add 1 over here and a half more. and see if I contain that value. So half of this, if I add it, what happens? Does it include it or does it exclude it? Who did this or saw it? So I want to do 1.5 of those. Is it inside or not inside? So that's what 1.5, so 1.5 of the IQRs will give you. All the calculations are done over here. Or is this the spending data? This is the other data set. Okay, I'm going to go back. So 1.5 times IQR. Let's do it. I do it in the notes. So IQR in the other set of notes. IQR times 1.5 is equal to 1.5 times 19. And how much is that? $28.5. Now take 33 plus 28.5, and what do you get? Lots of calculations, but stay with me. We're just going to find out if we cross 61 or we're within 61. What does this make? Look at that. 61.5. So technically, this goes right here. So are there outliers or no outliers? No, there's none, you guys. This is showing me if I catch it. If it's outside, there's outliers. But we went up to 61.5, so it's included. Yeah, outliers are outside. Okay, good. So this was worth it, you guys. Outliers are outside. Let's make sure we did the calculation right. So your feeling is that, okay, it is very extreme and still worthy of investigation that he got 61 in a single year. But statistically speaking, it's very borderline. It's actually because of his uncertainty in his home run hits, it causes the IQR to be wide, and it does include the 61, but just barely. So it's still borderline. It's still something to investigate. Are you guys good with that? So what you got to do is make the calculation, make the box. That's why drawing is really going to help you here. If you have to draw, use a ruler. But then the calculations will confirm. You see, because I wasn't sure if it was below or above, but this made it 61.5. So it includes borderline. All right, so if you guys did this all right and have the wrong conclusion, I just take off a mark out of 5 or 10 if it's out of 5 for 1/2 of the analysis. Okay, questions. Are you guys with me? I think that was worth it. So that's that. You know how to make a back-to-back stem and leaf plot. You know how to do the 5-number summary. I did it very quickly there with small data sets. It's feasible. If you guys need more time on the quiz, put it in the chat so I can give you more time. I don't mind giving you more time. The question is, do you guys have to go somewhere? And I want to make sure it's fair. If people have to leave after 12, I don't want to go too far past 12. but keep me posted. Anything else? I think I did a little bit of everything. I can put it till 12. I have no problem. If anyone can test that, let me know. Oh, there's some questions here. Okay. Guys, don't worry so much about the quiz. Just do your best. I know it's stressful. This is the only way I can test you, and I'm very lenient. All right? I'm going to be very lenient. Just do your best. If you need more time, I can give you more time. Just text me in the chat and I'll give you more time. If you have to leave and you feel ripped off because you don't have more time, let me know that too. But I can give you guys more time. I don't care. I can stay here. Okay? If time is the issue. But you have all the materials. You have all the materials you could reference. You just have to organize yourself for the quizzes, put all the important things together on a page and use that paper. It's very early in the semester to judge yourself, okay? It's a lot of material all of a sudden. You're going to be experts by the end. Don't worry. All these quizzes are going to be worth it. Okay? And then as far as the language goes, we have to talk about that. I asked people who have trouble with the language, I can meet them outside of the class. You know, this class is not, the videos again are all bilingual. And the notes are bilingual. These sessions are just review. If you want review in Spanish, I mean, I'll do my best, but we can meet, but it has to be on a Thursday, probably, or sometime during the week. I tried to meet with students this week and they didn't have time. All right. So don't worry too much. Just take a deep breath, say a prayer, relax. It's really not a big deal, okay? It's just you're gonna try it and it's gonna heighten your comprehension to do this. I don't want to, sometimes, you know, the stress can make you freeze, but don't, so if that's happening, just let me know. I can give you some more time. And if there's really a need, we can, at the end, you know, towards the end, I can repeat some of the quizzes. Okay. I know there was a lot of material this week and I know you have obligations. That's the challenge of this online program. Okay. Javier is asking me to look at the stem and leaf again. Where did I draw it? Yeah, reading notes is not going to get you through this class. You need to print the notes. I would recommend printing the notes and working on paper. Okay, that is the ideal way to deal with this. I don't know where I drew the stem and leaf now. I lost my drawing. Was it here? Was it here? My drawing is gone. This is a solution, but I seem to have lost the problem. Okay, the quiz is going to open at 11:20. Do the best you can do. We never got to talk about Excel today. You can do all this on Excel, you know, as well. But I want you to show me your work, so it's going to be manual today. But we can talk about that next week. Next week, I'm going to talk about normal distributions. That's going to be what you study this week. So again, you need 10 hours a week to work on this stuff, minimum. If you need my help, make an appointment. We can meet on the weekdays. All right? I think this is it. So I'm going to talk a little bit about this drawing. but otherwise we're gonna go. So I don't, Javier, what is the issue with this? I'm gonna go back. What is the question that you have about the stem and leaf, Javier?
Well, I don't know how to put the data off from the other person on the group one on the
I just did it. Where were you? Were you there?
yeah, I was there while I was attending, but I get confused sometimes because of the where is put where to put the data.
Over here.
Yeah,
0,
no.
8, 1, 2, 1, 3. This is the first digit in the stem. This is the second digit in the leaf. So this is 12. This and this are 13. This and this 16. This and this 16. 21, 25. That's how
Okay,
it's.
I understand. But where do you get the 3683? The thing is that I didn't study for this part that much. I studied for the other parts like the Q and R and the Q1, Q2, Q3.
Well, you need. Okay, so I emphasize no matter what, you have to draw your data first. You need to express the data first. Okay.
Okay, okay.
And so you need to know how to draw it. So I just did it. I don't know where my drawing disappeared. I don't know where it went. But I did it just now. And so you got to separate the data, put it in order. Here. So you put it in order. The first digit is this one. So you first make the stem and then you start putting the data. So you start 0, 1, 1, 2, 2, 3, 3, 4, 4, and you understand that's the middle. And
Yeah, I
then
understand that.
you start putting 0 is the first one, and then 8. And you have to put them alineado, right?
Sí, sí.
So the next one is 12. So there's 1 and 2. And then 13, 1 and 3. The next one, 16, 1, 6. The next one, 16, 1, 6, right underneath the other one, like that. That's how
Okay.
it works. Okay?
Yes.
Okay, other question. Oh, it's starting. Okay, so the quiz is starting. We have to get out and back in. Write me an email to make arrangement to meet me. You can start now, but we have to get out and start again. Okay, I'm going to get out of here and come back. See you in a bit.